Hello guys, I am Soham Lakhote, currently a third year PhD student in the Indian Institute of Science Bangalore, and my research area is in the domain of analog and RF circuits. So I welcome all of you for this week 0 assignments solution. So in this session basically I will be presenting you the solutions for the week 0 assignment that was released, and it won't be a graded assignment for the course, and I'm an official PMRF NPTEL TA of this course. So coming to the first question, let me turn on the pointer. Yeah. So coming to the first question, it was given that you had a hollow metallic sphere of radius 2 meters, and the potential was 1 volts on its surface. So as you know, it's a metal, right? Inside the metal, there cannot exist any field, right? So for 2 points to have a potential difference, there must exist a field between them, right? So when the field is zero, then the 2 points are equipotential, and since the field inside the conductor is zero, that's why the metal is a equipotential. That's why the field inside the metal as well as on its surface, sorry, the potential inside the metal as well as at any point inside the metal as well as on its surface should be equal, right? So at surface it's given 1 volt, and hence even inside at any point inside the what you can say inside the sphere, it should be 1 volt as well. So this was the solution, and it was a very easy question. Now coming to the second question, like it was given you had the two charges, one charge was a positive and another one was the negative with the magnitudes given in the question. So you were asked like at what point basically the potential due to all two charges, due to both these charges, will become zero. So as you know, the potential due to a charge at a particular point which is at a distance r, it's given by kq by r, right? So now if you add the potentials due to these two charges, it should sum up to zero at that particular point. So assuming that let that point be at some distance x from charge q1, right? Because this is what has been asked in the question. So the potential due to the charge q1 at point v0 will be kq1 by x, and similarly since the both the charges are separated by 1 meter, this the point 2 will be separated with the point v0 by 1 minus x distance. So this is just I'm just setting up a very simple equation: kq1 by x plus kq2 by upon 1 minus x equal to 0, right? So the kk will be cancelled, you know, q1 and q2. So from this you will get the x upon 1 minus x term, and from there easily you will be able to find x is coming out to be 0.83 basically. So now moving to the third question, the net capacitance. So basically you were given the two series capacitance, and the value of the equivalent capacitance of the arrangement in the first diagram was given out to be 1 femtofarad. So as you know, the two capacitance when placed in a series, they will be equal to C by 2 basically. So its value is given as 1 femtofarad, so C is nothing but 2 femtofarad. So when the same two capacitors are placed in the parallel, then their net equivalent capacitance become 2C. Since the value of C is 2 femto, the equivalent capacitance automatically becomes a 4 femtofarad. So again, this was a very easy question. Now coming to this question, so let's understand what is the difference between the active and the passive element. So as you can see, the anything basically that is able to deliver the energy, we cannot term it as a passive. So the passive element will always consume the energy, or it will not do anything. For example, resistor, it dissipates the energy, right? Whereas for the components like L and C, they do not dissipate the energy, but they do not generate the energy as well, right? So for active element, they should be able to produce some kind of energy. So basically if you consider the voltage source, then you know basically because of the chemical reactions in the battery, you are able to give the energy, and that energy is being dissipated in a particular load, right? So that's why your voltage sources and current sources are active elements. Now considering the case of a transistor, so as you know, when you give an input signal to the transistor, let's say input signal has some particular power, now the output signal will be having a power which is greater than the input power. So your transistor is having some inherent power gain within it basically. So that means it is adding, so basically it is amplifying the power, right? So that's why it is also called as an active element. So in the question it was given the D option, which was given like the voltage source is an active element, that's correct. But the C option, the current source is an passive element, is a wrong answer for the reason that I had just mentioned a few seconds back. So now coming to this question, like as you know, so this is a again the two capacitors placed in the series, so their equivalent resistance is given by this 20 into C divided by 20 plus C, so this is given as 4, and you just need to find the value of C basically. So this is a very easy question again. And coming to this next question, so it was it was a continued version of the previous question. So the C was found out to be 5 nano farad, right? Now what they have given is like you have applied a battery of 1 volt across this across this arrangement of capacitors, right? So the what we need to calculate is the voltage drops across each of these capacitors. So as you know, the voltage drop across this capacitor should be equal to the voltage of this battery. So this is what has been written in the equation number 1. And as you know, the charge principle, the charge on the capacitor is C into V, right? And here also it's C into V. So whatever charge sharing was supposed to happen, it had already happened, and now the charges of these capacitors should be equal to each other, and that's why I had written this C1 V1 equal to C2 V2. And if you just put the values of C1 and C2, then you will be able to get V2 is equal to 4 V1. Now solve this equation 1 and 2, and you will be able to get V1 is equal to 0.2 volts and V2 is equal to 0.8 volts. So that's why 0.8 volts is the correct answer. Now coming to this question, it's basically it's a simple question based on the Gauss law. So basically, what does the Gauss law says? So electric flux basically passing through the surface because of anything, maybe it may be a line charge, it may be a point charge, is nothing but the integral of E into dA, right? Correct. So what is this? So this is the integral E into dA. So what I had done, this is a sphere. I had taken a area element on the surface of this sphere with area dA, and this green is the normal, right? So why I have taken this normal? Because the electric field and the N that you are able to see, so I have to take a dot product of that, right? So if they are not aligned, then I have to do E into dA into cos theta, where theta is basically the angle between the electric field vector and the dA basically. Since they are aligned over here, I can just write E into dA over here, but it is not a dot product got converted into simple multiplication. Now what I am going to do is like as you know, the electric field, is it varying with the dA, right? No, it is not varying with the dA. So I can take the E outside and I can just integrate the dA, which will come out to be A. Now this dA, when I have taken only over here, but when you take this dA anywhere on the surface of the sphere, it will come out to be the same, and hence this I can do this integration of dA as that A basically. If the surface was not uniform, if it was some rigid object of whose shape was not like a sphere, then you have to keep this dA within the integration. So now this phi is equal to EA. Now you know electric field, because of this point charge at the surface, this surface which is placed at a distance r, which is nothing but the radius of the sphere, is given by k cube by r square, right? R is the radius, and the area of surface area of the sphere is 4 pi r square, right? Now this r square will get cancelled, and this k is 1 upon 4 pi epsilon naught, right? So again this 4 pi get cancelled, and this phi, that is the electric flux because of the point charge through the surface of the through the sphere, will be given by the q by epsilon. Now was there any other way to solve this question very easily? Yes. So I had just shown you one part of this Gauss law. So another part says this electric flux will always be equal to the charge enclosed divided by the epsilon naught. Now in this sphere there was only one point charge that was enclosed within the sphere, right? And what was its value? Plus q. So that's why the q enclosed become plus q, and this electric flux directly came out to be plus q by epsilon naught. We didn't have to do any this type of calculation. You will get this answer in one line, right? So this was the solution for this particular question. And coming to the next question, so it was the same question, but the object was changed. It was moved to the cylinder, and again basically if you just use the Gauss law, basically it tells you the electric flux basically through the cylinder will be nothing but the q enclosed by epsilon naught. Now this object is enclosing this charge, right? So this point charge is present inside this object. So again the charge enclosed by this particular object will be equal to the charge, the value of the charge basically, this point charge basically, right? So this q enclosed become equal to q again, and this electric flux will be again equal to q by epsilon naught. Note that the solution given minus q by pi epsilon naught is not correct and is a wrong solution. So please take a note of that. Yeah, thank you.